Welcome to AWE 2021. You are our first virtual panel here in the developers room. Nice to see you. And I did the intro, but I will allow you to tell us about yourselves. And here we go.
Sure. Thanks for joining this session. We're excited to be here virtually. Wish we could see you guys, but happy to get to talk to you. So I think I've been introduced. My name is Domingo. I am a developer advocate on the XR team. Sergi.
I'm Sergi Tortosa, and I'm also developer advocate at the VR HP team. So we're doing the same. So I'm gonna get started and talk about a little bit about Omnicept and how to kind of like develop a little bit of VR smarter with cognitive load. And the first thing we get there, it's oops, I don't see my slides changing. Okay, I can still talk and try to move the slide forward when we can. So first thing we are having on the mix to get VR a little bit smarter. Oops.
Ooh, maybe it's a little delay.
Yes. That's hard to control the slides from remote. But yeah, first thing we need is the Omnicept VR headset. Many of you or some of you may be a little bit familiar with HP VR headset. So we introduced the G2 headset. That's kind of like the next generation of VR for HP, and the G2 introduces like better graphics quality, better lenses, better speakers. Kind of like we improve everything we could from the G1 to G2. We also get like 4 cameras instead of 2. So kind of like it was like the next step for HP to get on VR. And in top of this G2 great headset, we added a bunch of sensors. And in collaboration, kind of like with Tobii, Valve, and Microsoft, we get like both G2 and G2 Omnicept. So what's different from the G2 and the G2 Omnicept? Oops, click to forward. So the things that are different, it's that we added a bunch of sensors on the G2 Omnicept. Being those PPG sensor on the forehead, that's the similar that you will see on your smartwatches to measure heart rate and heart rate variability. We got a face camera on the lower part so you can see the mouth of the user, and we got eye tracking powered by Tobii, so we can get biometric and eye tracking. This also enabling for us foveated rendering, that you will be familiar with that, but that's enable us to do foveated rendering using both BRS or BRSS2 from NVIDIA. So kind of what's Omnicept and what's not Omnicept? Just to be clear, you come from an OpenXR talk, so we are not OpenXR trying to make the OpenXR work. They do an amazing job there, and I'm sure you love that. So we are not XR rendering calls. We are not an interaction toolkit, and we are not support for different eye trackers from Tobii. We only support for now the HP headset, but we are an SDK that provides access to the different sensors that we have. So you will have raw access to the eye camera, the eye tracking data, the pupillometry, the heart rate, variability, and we also add cognitive load. That's Lauren will be talking more about what's cognitive load and how you can use that on your applications. And as I said, we also include a little bit of on our SDK hardware simulator, so you can test it first, right, and start developing and see how Omnicept works, and then move on. We support Unity, Unreal, C#, and C++, right? So almost, I think we got almost everything covered. Sorry if there's any developer for a different engine. We don't support that yet, but happy to listen after on the Q&A. What's your engine and why you want that supported? So moving out like to what are the sensor data that we get? That's a funny image, just Lauren face. Thank you for letting us put that here. So we get you get from the eye camera, as I said, X, Y, Z position as a unit vector. You get the pupil size. And you get the openness boolean that lets you know if it is open or closed, similar to you will get with by Pro. Then on the mouth camera, we had 400 by 400 texture. That's because this is a black and white texture of the user. And finally, we have also like the heart rate that has like the PPG sensor on it, but we report heart rate for privacy reasons. And extra, we have an immudator and an IMU sensor that's not like the headset IMU. So we have two of those, one for tracking on the headset and the other for the sensors itself, because we need to kind of like take into account the user movement when we are calculating things. So a high-level overview on how Omnicept works. It's that you have different, I will select the image in a second, hopefully. So you have your clients that are the ones that you develop with your favorite language or engine. And those connect to the Omnicept runtime that's installed on the system. And then you get like the access to the sensor data. This has like, we have a licensing model for that, but mentioned that everything works offline, right? So there is like no data back to HP, there is no data needed on the cloud. Everything is like done on the premise on the computer, so you don't need anything else to get it working. So I'm not trying to. Can we move to the next slide, please? Okay, yeah, thank you. Thank you so much for that. So you can see here what I was talking about. That's kind of like the diagram that we have. You have the hardware on the left. Moving to the right, you have your clients. So you connect to the runtime, providing your access key and secret. If it checks just with the cloud for licensing reasons, not for other things, and there is no data to HP. And then you have like the stream of data getting back to your client. You can see like the hardware simulator acts like similar to what we do with the headset. You have a piece of software that's sending messages through the runtime and gets you to your application. And finally, I'm going to talk about, again, recall privacy, because I think that's important those days, and we are getting a bunch of sensors of the user face. So I think that's extra important for us. First of the things, it's HP does not collect any data. We do have an option to share data back with HP, but that's a thing that has to be enabled like kind of 2 times. First for developers. So we want to get developers to control of that, right? So you can decide if your application wants to do it or not. And when you decide that, it's like, actually you have to code that, right? So there is no better way to have control over something that you have to actually do a line to say, hey, I enable that. And the second part of it is the user has control on their systems of what applications are accessing which sensors. You can imagine that as the Android permissions, right? I want to know which applications are accessing my data, which applications are accessing my age tracking, and so on and so forth. So we give the ultimate kind of like control to the user that can block any application or can allow any applications through the Omnicept runtime. So I have spoken out, and now we were going to dig more on the session about cognitive load and how you can use that. Lauren,
Awesome.
up to you.
Thank you, Sergi. So I'm going to talk to you a little bit more about cognitive load for those who aren't neuroscience specialists in the room. So one early pioneering research finding showed that the changes in cognitive load during tasks results in proportional changes in physiological signals across multiple biometric sensors like heart rate and pupil diameter. And then you combine that with users' self-reported cognitive load, so what they said their cognitive load was during these tasks, we create a way of detecting cognitive load. So since our headset's able to pick up eye tracking features and heart rate, we were able to train machine learning models to recognize trends in tasks, and based on in the tasks, we have the biometric sensor data as well as the individual's reporting data, and we're able to predict cognitive load. So yes. So I'm sorry, I'm moving all around here. Great. So next slide is our Omnicept SDK that Sergi was just talking to you about, gives you cognitive load as an output. And we say cognitive load is the amount of mental effort to perform a task or to learn something new. So if your cognitive load of your user is high, what does that mean? It could mean that your user is overwhelmed. They're not learning, they're not in a flow state, their performance is impaired. If their cognitive load is really low, it could mean that they're disinterested or very relaxed. It really depends on what you want to do with cognitive load in your application and what your outcome is. So, the example of training, you would want them to be what we call the Goldilocks zone or the flow state, which is, it's right above their level, so they're really engaged, but it's not too high above their level that they're at this overwhelmed cognitive load state. So, but if you're creating, say, a wellness app, low cognitive load might not be a bad thing. You might want your user to be relaxed and not, focusing on a lot of different things in your scene. So it really depends on your user application. You do some research with what you want your outcomes to be and what you do with cognitive load within your app. I'm talking more about that. What can you do with cognitive load and kind of how is it coming through? So cognitive load from the SDK is coming as a float value. So it's between 0.1 and 1.0. You could think of this as 1% to 100% of cognitive load. When you get a reading of 0, that means there's no cognitive load being sent. So either we're not getting eye tracking features or your heart rate, so maybe the headset's not on, or the headset's still calibrating. So when you first put the headset on, you give it about a minute, less than a minute, for it to calibrate to each user and to their cognitive load level. So now you're getting cognitive load data to your app. You're in Unity or Unreal or in C++. You're connected to Omnicept. You integrate the plugin or the library files, and now you're getting cognitive load. So what can you do with that? I'll give some examples. These are not to say that these are the only ways to use it. In fact, there's endless ways to use it, but I'm saying this, some ideas just to get your design thinking ideation phase started with how you could use Omnicept in your app. So branching, for example. Branching, to describe that easiest, is, adjust the difficulty of your experience. If it's a game or if it's training and your user has had high cognitive load for the past few minutes, you might want to make the next scene easier or give them some helper task or adjust what the experience will be based on cognitive load. And you could do, similarly for low cognitive load, change what happens next. Another thing you could do is maybe not change the experience, but give some tips or pointers. So, say you're in like an escape room or a puzzle room and your user has had a high cognitive load and they're not making any progress. Maybe you highlight something, give them a clue by highlighting an object or giving them a verbal clue. You know where their eye gaze is looking, so you could do interesting things there. And then we all kind of are familiar with like getting stats at the end of doing a game or something, like how good was your accuracy if it was like a shooting game, or how quickly did you complete a task against like how everyone else completes it. So you can use cognitive load as an experience indicator for somebody. So they go through a training simulation, and at the end of it, you tell them how they did, what their performance was, like what their grade was, or areas that they had high cognitive load. So you can give feedback so the user is more, they can use their application better to serve them, knowing more information about themselves. On the left-hand side, you'll see, this is using cognitive load in training and expertise indicators. So you'll see performance and cognitive load going along the x-axis. So in the beginning, when you haven't spent a lot of time training, your cognitive load's really high and your performance is very low. And as you spend time training, your performance goes up. You become proficient and eventually you become an expert. And you'll see what happens with cognitive load is it kind of normalizes into this, Goldilocks zone and then getting comfortable, which would be a good state to then, move on to the next module if it was a training module to continue and to get into that Goldilocks zone. So I don't know how this video is going to work, but I'll try to. We have had some, I don't know if I could hit play. So we have had some ISVs who've integrated Omnicept into their apps. Let me see if I hit play again. Is that, okay. It's probably kind of moving for you. So there's, this is a training for an electrician, and then I will talk quickly about all the things you're seeing. Then this is soft skills. This is Ovation using cognitive load with speaking, training, getting comfortable with speaking. And then this last one was a game experience, kind of using cognitive load they use it tips pointers. So as the game gets more difficult, your cognitive load is high, they'll make it a little bit easier for you by highlighting and helping you know what to do next. So let's see if I can play it again. So yeah, electrician training, and you'll see that there's heart rate and cognitive load kind of on like a watch. So you could like look down and see where you're at. In that experience, there's also a web module you log into later that kind of gives you that where your cognitive load spiked and how you performed based on the different tasks. And then that second one is Ovation, and that you might have heard of them before. They help with doing public speaking like this, like do your preparations, and when you're real world ready, based on heart rate and cognitive load. So the last slide I have here is, you're interested, get started. The one website we want you to be aware of is hp.io/Omnicept. That's where you can get the SDK and get started. We have a video on YouTube. You could just search Getting Started with Omnicept. It'll walk you through how to get started for Unity and Unreal and start getting cognitive load into your application. And if you go to hp.io, there's documentation, downloads. In that video, you might have seen there's like an overlay app in the top left-hand corner. We have a download called Omnicept Overlay. So if you have an Omnicept headset, you can run any VR experience you have today, put the Omnicept overlay on it, do a recording of your screen, and then you can watch it back and see what your cognitive load was over, any game that you have or any experience you have to kind of give you an idea of how to use cognitive load. So that's already all up for free already. So I think that's it. Thank you for listening.
Thank you, Lauren and Sergi. Round of applause. I think we have a question here. You have time for a question or two? I think so. I think that's a yes.
Sure. Yep.
Hi, I'm Valentin. In terms of the load on cognition, how do you segment on what exactly the load is and what part of the brain? From the examples they showed, for example, the electrician and the stash the trash, it's like hand-eye coordination versus recollection involve different parts of the brain. So is your training data aligned to one more than the other, or which one's more reliable to use to get that single floating point value on what part of the cognition is being loaded or overloaded? Thank you.
We can answer. I didn't know if there was someone. I didn't know if our HP Labs expert was in the room with you guys. But yeah, so the cognitive load model was trained, and so if you actually go to hp.io/Omnicept and then click on research, we have all of the background information on the modules we trained the cognitive load algorithm on. So they were tasks. So I understand your point about like hand-eye coordination and getting over that hump of VR. So generally we do ask that when you are figuring out how you're going to use cognitive load, like go through a whole session. I mean, let someone get comfortable with VR, because that in itself has its own cognitive load, people getting comfortable. So that is kind of, you want to get past that to then that stash the trash is coming along on the conveyor belt and throwing it. And yes, maybe your hand-eye coordination is giving you some bumps, but if you take an average over the whole session, you'll see that your cognitive load goes down over time as you learn. So kind of taking more samples is how you get an overview of what the experience was like for somebody.
Okay, we have a quick follow-up, and then we're out of time here.
Yes, sorry, just one correction. I meant what specifically are you loading? Not how do I know that this load is overloading because there's some training data that you measure this on. How do you know that you're measuring this on the motor cortex versus, say, the cerebral cortex, and something that functions on one's responsible that one part of the brain versus another? What is exactly being loaded?
I don't feel like I am the expert to answer that, but we do have someone on our team that could help. So I would say we should follow up with you. You can reach out to us. If you go to the website and you click support and get in contact with us, we can get our PhDs who are behind this algorithm to get in a conversation with you. But I do also say check out our website, because that's the white papers from our labs team. We could help you integrate it, but we're not the scientific experts on all that, unfortunately.
Thank you. Lauren Domingo, thank you, for XR Developer Associate at HP. And thank you, Sergi Tortosa, XR Developer Associate, or Advocate, I'm sorry, at HP. Thank you so much. Let's have a round of applause.